All right, today we're covering 3-4, which is linear programming. So we're going to learn how to solve linear programming problems. First, we want to define what that is. So linear programming is a method of finding maximum or minimum values that satisfy a given set of conditions or constraints. And we're going to see what these are next. So a constraint is just one of linear inequalities in a linear programming problem. So it looks just like a linear inequality that we were graphing in the last section, which is why this section comes right after that. We're going to set up a bunch of linear inequalities and graph them. And the intersection of all the shaded parts of those linear inequality graphs is what is called the feasible region. This is a solution to the linear programming problem. So let's look at an example. This example is about a bakery. They bake two kinds of bread, A and B. So one batch of bread A needs 5 pounds of oats and 3 pounds of flour. One batch of bread B uses 2 pounds of oats and 3 pounds of flour. And the company has 180 pounds of oats and 135 pounds of flour. So the first thing you want to do is identify your objects, because linear programming problems are dealing with objects. In this case, we're dealing with breads A and B. You're going to want to set them equal to variables. And since we're working on the XY grid, the easiest thing to do is let one of the things be X. So we're going to let bread A be X, and then the other one can be Y. So Y is going to be our batches of bread B. Once we have that, we're going to look at our constraints, or what are we limited? Where are our limits? And our limits are basically in the amount of material we have. We only have 180 pounds of oats and 135 pounds of flour. So how much flour and oats are we going to use, or can we use? Well, they depend on the number of batches of bread A and B that we bake. So our first constraint, well, actually our first constraint is, since we're dealing with objects, these are probably going to be your first constraints 90% of the time. X has to be greater than or equal to 0, Y has to be greater than or equal to 0, because we don't have negative objects. The next constraint has to do with our limitation on oats. We have 180 pounds. We can't use more than that. So we're using 5 pounds for each batch A bread that we make, and then we use 2 pounds for each batch of bread B. So the 5x plus the 2y has to be less than or equal to 180, because that's all that we have. Now we're going to look at oats. We use 3 pounds of oats for each batch of bread A, so 3 times A plus 3 times Y, because we use 3 pounds for each batch of Y, and it has to be less than or equal to 135, which is the amount that we have. So these are all our constraints. If you look at this, the problem, it doesn't have any other constraints written in. And now we want to find our feasible region. So to do that, we're going to graph the feasible region by graphing these 4 linear inequalities. The first two simply are these. So these put us into quadrant 1. And essentially we don't need to graph anything else. We just are going to eliminate quadrants 2 through 4 in our linear inequality graphing. Next, we're going to graph these and find the feasible region. All right, so I've graphed my 2 linear inequalities. The easiest way to do it, and a good way to do it for linear programming, which you'll see in a minute, is graph by finding the intercepts. So here I set y equal to 0, and that gives me x is equal to 180 divided by 5. So my x-intercept's at 36. When x is equal to 0, y is equal to 180 over 2, or 90. So those are the points that I plotted, 36, 90, drew my line. Here, when y is equal to 0, x is equal to 135 divided by 3, or 45. When x is equal to 0, y is equal to 133 divided by 3, or 45. So here are my 2 points for that, and I graph that. And notice I want to be underneath, because both the lines are less than. So the feasible region is this blue shaded area here. Any point in that region is actually a solution to this system of linear inequalities. One thing you're going to want to do when you're graphing is identify specific points, and the points I'm talking about are these vertices, and they call them vertices up here. So this is a vertex, this is a vertex, this is a vertex. It's kind of a corner of your region. These are easy to find, and we know what these are because we solved by finding our intercepts, and that's one of the advantages to graphing by finding your intercepts, because it gives you your coordinates of some of your corners. The only point it doesn't give you is this intersection. Because my graph is pretty accurate, I can solve this, and this is just a system of equations. It's a system of those two equations. 5x plus 2y equals 180, and 3x plus 3y equals 135. So I could solve them by substitution or elimination and find that intersection point. But because my graph is pretty good, I can see that this point here is actually at 3015. So either way, graphing, substitution, or elimination, you're going to want to find any corners, including intersection points, in order to get to the next step. And notice they have it listed, and we're going to use these when we get to the next part of this of linear programming. All right, so your check it out is going to be to graph this system of constraints and find the feasible region. So you need to find the shaded region, and I also need you to find the vertices of your feasible region, because we'll need that for the next part. You'll need that for your next part of your check it out. All right, so the objective function is the next part of linear programming. Objective function is the best combination of values that allow you to maximize or minimize a certain function. So the objective function may have a maximum, minimum, or neither or both, depending on the feasible region. How do you know? Well, you can know by looking at your graph. This is called bounded, so it's bounded by your x and y axis. This has both a minimum and maximum value. Unbounded, you can see these aren't bounded by this the xy axis, and they have either a maximum or minimum value, but not both. So that brings us to the vertex principle of linear programming, also called corner point principle. This, if you look at this feasible region, this was probably two lines that intersected at this point. And as I said, so our feasible region would have these vertices. This principle says that if an objective function has a maximum or minimum value, it must occur at one or more of the vertices of the feasible region. So instead of having to check every point in this feasible region, if I want to maximize or minimize something, I only have to look at 4 points. This is really nice. It minimizes our work for maximizing or minimizing a particular thing. And so our next slide is what we're going to try and maximize or minimize. So our bakery wants to maximize profits, which most businesses do. So it says one batch of A yields a profit of $40. One batch of B yields a profit of $30. Use the profit information and data to find how many batches of bread the bakery should bake. So what's our objective function? We want to maximize our profit, and we make our profit by selling our goods. So we want to maximize this 40A plus 30B. We want this to give us the maximum amount of profit that we can possibly make. And that's given the constraints that we have. So this is our objective function here. And it's not in the form of y equal or anything. Usually they call it objective function, but it's usually just an expression. All right, so this was our feasible region that I graphed. We had the following vertices. 0, 0, 0, 36, 0, 30, 15, and 0, 45. So these are the only points that we really need to worry about. This point, this point, this point, this point, this point. So we're going to take those 4 vertices, plug them into our objective function, and see which one maximizes our profit. And that's what they've done here. So here's our vertices. Oops. This is our objective function, and then this is our profit. So by plugging the x and y coordinate in for x and y here, this is our batches of A, this is our batches of B, and calculating what that gives us, we see that at this point, if we make 30 batches of bread A and 15 batches of bread B, that's going to maximize the profit. And so that's how many that the bakery should make if they want to make the most profit. So that is a complete linear programming problem. It's fairly complicated, but each step is something that we know how to do. And you can see it's a very useful type of concept that can be used out in the real world to help predict and minimize things. So your job is to take this set of constraints, which you graphed the feasible region before. You'll need to have your vertices, and you want to maximize this objective function, 25x plus 30y. So you're going to take your vertices of your feasible region, plug the x and y coordinates in here, and figure out which one maximizes this particular function. So that wraps up linear programming. Write down your questions, and we'll go over the check it outs. I'll see you next time.